So, welcome to chemistry practical class and lesson. So, my name is Jack. Call me Mwalimu Jack. And chemistry paper 3 is one of the papers in chemistry, 1 and paper 2. And we are going to learn chemistry paper 3. And before we proceed with our lesson, the first thing to be done is to be able to know the objectives of chemistry paper 3. So first objective that the student should know is the student should be in a position to select and handle the apparatus that are used in chemistry or in practical. And secondly, students should be in a position to be able to use theoretical understanding of chemistry to be able to make accurate observations and as well draw conclusions and observations that are made during chemistry practice. Finally, the student should be in a position to be able to make accurate measurements, and that depends with the operators that provided. Like stopwatch, the student should be in a position to make accurate record of time, also temperature and volume. Our next is areas that are commonly tested in practical paper 3. So one area that is commonly tested in chemistry practical or paper 3 is qualitative analysis, which incorporates organic and inorganic qualitative analysis. Then secondly, we have the quantitative analysis, and which is also called volumetric analysis, also called titration, what students is best. And then finally, we have the reaction rates, solubility, or energy changes, or enthalpy change, what we call chemistry. And the competency that is basically tested here is the graphs. So students should be able to know the shape of graphs that they expect to obtain reaction rates, solubility, and enthalpy changes. When it comes to quantitative and qualitative, qualitative analysis is about what is in a sample, that is the ions, while quantitative is how much is in a sample. So this is where the student is able to determine the quantity of a substance in a particular sample. So, and the two analyses are used together in qualitative, what I mean in analytical chemistry. Commonly used question techniques in qualitative analysis in inorganic qualitative analysis, which is basically analysis of salts, ions, is flame test. You will be able to learn a lot when it comes to flame test. The second one is solubility, where students will be able to test or to observe whether the test substance dissolves or does not dissolve in water. When a substance dissolves in water, the student should be able to know and identify or recognize the color and mention that in the observation. So it can be colorless solution or green solution or blue solution. So the substance can either dissolves or it cannot dissolve. So when it dissolves, the student should be able to mention it. Then the third one is effect of heat on compounds. Again, we'll be able to do a lot on that. Then we have determination of ions, that is metallic ions and anions or radicals, and that is in solutions or aqueous solutions. While in organic qualitative analysis, the questioning technique revolves around heating of the substance, test the unsaturation of hydrocarbon, also the pH value of test substance using the provided reagents. The reagents that are provided are universal indicator and pH chart. Then the third one is esterification reaction, and this reaction resonates around organic acids, alkanols, or alcohols, and maybe with few drops of acid. So we'll deal with these later on. Then we have the functional groups that are commonly tested in organic analysis. We have the saturation, that is double bond, triple bond. Have the alcohols are of each group. Then we have carboxylic acid or organic acid, the RC double bond OH. So that is, those are the functional groups that are commonly tested in organic. Then we have that before a student carry out a practical, the student should be able to know what is expected. And the student should be able to accurately identify the test reagents that are provided, only knowing them, but should be able to know what the reagents test, and also should be in a position before even embarking on a practical to be able to predict. The moment the student sees a reagent, the student should be in a position to predict what that reagent is expected to test, what are the respective observations that the student is expected to make, and the inferences that goes with the observations. Then we have the test reagents that are used in organic qualitative analysis, and for the test for metallic ions. And the commonly tested metallic ions are the ones that are here. We have sodium ion, potassium ion, ammonium ion, calcium ion, barium ion, magnesium ion, aluminium ion, zinc, lead ion, copper 2 ion. We have iron 2 ion and iron 3 ions. Then the reagents that are commonly used here is aqueous ammonia. We have aqueous sodium hydroxide, which are basically used in preliminary test in qualitative analysis. We have potassium iodide, which is used as a confirmatory test reagent for lead ion, whether it is present or absent. Then we have this category here of sulfuric 6 acid dilute, which is mostly 2 molar. We have sodium sulfate solution, potassium sulfate solution. So this solution can also be used as confirmatory reagents in qualitative analysis for metallic ions, most likely confirm lead or presence or absence of lead ions. We have also hydrochloric acid, we have sodium chloride solution, we have potassium chloride solution, which are also used in confirmatory test for the metallic ions. Other substances that can also be there provided is the litmus paper. Anions, we have the sulfate ions, sulfide ions, carbonate ions, chloride ions, nitrate ions, and hydrogen carbonate ions. These are the ions that are commonly tested, and students should be in a position, candidates should be in a position to know how these are tested, and that is based on the reagents that are provided. So the reagents includes lead 2 nitrate, barium nitrate, silver nitrate, 2 molar nitric 5 acid, and we have hydrochloric acid, we have acidified potassium dichromate. So the first three are commonly used in the preliminary test for ions, while the last ones are commonly used in the confirmatory test. That depends with the test substance and also the procedure or steps that the students are to follow. Our next is the test reagents in organic qualitative analysis, and the test reagents that are commonly used includes universal indicator and pH chart. And the pH chart ranges from pH value of 1 to 14. We have acidified potassium manganate 7, which is also a very important reagent when it comes to organic qualitative analysis. We have acidified potassium dichromate as well, which is a test reagent. And students should not confuse acidified potassium dichromate 6 when it is one of the test reagents provided, because it can be either used for qualitative and also it can be used for organic or inorganic depending with the instruction steps. Then we have the bromine water and we have sodium hydrogen carbonate. So those are the reagents that are used, and the expected observations includes test substance dissolves to form a colorless solution. If students are to test the solubility of a substance, then they are expected to infer polar organic substance if it is organic substance. The second expected observation is the heating of a particular test substance. So if the substance burns with a sooty or smoky flame, then the student is expected to infer the double bond or triple bond, the unsaturation, and the student should ensure that the part of the flame that is used is blue non-luminous flame so that the student cannot mistake the observation. Then we have acidified potassium manganate 7. If it is decolorized, then again there the student infer the presence of double or triple bond. If it is not, then the double and triple bond is absent. Bromine water, if it is decolorized, then double triple bond is present. When the bromine water is not decolorized, then double or triple bond is absent. Another term that can be used here when you are dealing with acidified potassium manganate 7 ions, a student may write or can write that purple acidified potassium manganate 7 changes to colorless. That is accepted. And when it comes to bromine, a student may write orange bromine water changes to yellow. Orange bromine water changes to yellow. So those terms can also be used, but not terms. So the term terms, because the chemical change is not applicable. Uh, we continue. When acidified potassium dichromate changes from orange to green, then that confirms the presence of ROH. When acidified potassium dichromate 6 does not change, then the alcohol or ROH is absent. When a student is given sodium hydrogen carbonate and is asked or required to add to the test reagent and the student observes effervescence, then that means that that test substance is acidic and the student infer the functional group that is there. If the student is given universal indicator and a pH chart and the student observes the pH values that are indicated here, then the student infer strongly acidic. If the pH values is within this, then the student infer weakly acidic. And the student should not write the range. It is either 1 or 2 or 3, but not 1, 2, 3. So that is not applicable. When a student is asked to add a carboxylic acid, an alcohol to a test reagent and with few drops of sulfuric 6 acid conc and is asked to warm and there is a pleasant smell produced, then the student infer the functional group of the carboxylic acid. If the reverse, that is instead of adding alcohol, the student adds now the acid, then the student infer the functional group that is alcohol. Then thank you very much. So this was just an introduction of chemistry practical paper 3. Our next lesson will be in flame test, which remember we say is one of the tests that is done in inorganic qualitative analysis. So thank you, and let's meet in our next lesson.